here we're trying to get the arc length of this curve, f of x equals e to the x natural log x on the interval 1 to 3. And we're told this integral can't be computed symbolically, which is actually typical for arc length integrals. So we're going to use a computer algebra system to approximate the answer to the thousandths place. All right, so our arc length formula is that a small contribution to arc is given by the square root of 1 plus the first derivative of the curve squared times dx. And so I can use an integral to add all these up. As x goes from 1 to 3. Now we need to compute this derivative. So f prime, you're going to use the product rule for this. The derivative of the first term is e to the x, leave the second term alone. Add to that a term where our first factor is left alone and the second is differentiated. All right, so I'm putting in all of that into this radical squared. And just at first glance, you can tell the chances of being able to do this symbolically are incredibly low. So it's not a surprise that it can't be done at all. E to the x natural log x. And I'll just call this e to the x over x for that term, and then I have to square all that. All right, no way you're doing that. So we're going to bounce to maxima. Okay, here we are in maxima, and I've typed in integrate the square root of 1 plus the quantity e to the x. So here's a reminder, that's percent e in maxima times the natural log of x, which is just log in maxima. That doesn't mean log base 10. Plus, oh, I forgot a percent right there. So percent e to the x over x, all squared. Okay. As x goes from 1 to 3. And I'm going to hit shift enter. And maxima just repeats the integral to me. It doesn't know what to do. So this cannot be done symbolically, and that's how maxima reacts. This is, however, a good chance to just double check that this is actually what we meant when we typed all this in, and it looks correct. So then we're going to go back and say, oh, what I want is a numerical approximation. So I'm going to use the quad QAG function for that. That is a set of 6 different algorithms that perform numerical integration. And you type in which algorithm you want, 1 through 6. It doesn't matter for us. The first number is going to be the approximate result of the integral. And I get 22.2 out of this. So approximately 22.2.